So dimension processing. To go into kind of an overview of this, the four steps that make up dimension processing are building attribute stores. So the attribute stores are what contain the actual member values in the attributes of a dimension. Then we have hierarchy stores. We have decoding stores. Hierarchy stores store the hierarchy of membership, so user hierarchies and things like that. That's where this information is captured. Decoding stores are what allow analysis services to quickly traverse the hierarchies. So it allows you to look up higher level members of a hierarchy based on the identifiers for lower level members of a hierarchy. And then finally you have the bitmapped indexes that again are there to accelerate the lookup of information within the dimension. So let's take a closer look at building the attribute stores. So if you have a typical customer dimension, perhaps not a typical one, but it's kind of simplified for this particular example. In this customer dimension, the customer is the key attribute for the dimension. And this represents the lowest grain that this dimension supports. And from the customer, we've got a couple of ways of aggregating those customers. We can look at customers by income, we can look at customers by gender, or we can look at customers by the geographical region that they exist in. So when we start processing this, analysis services has to process first the attributes in the dimension that have no other dependencies. So in this case, it's going to start by processing income, gender, and country because those don't rely on any other piece of information. It can basically process those in parallel and in isolation from any other attributes. Now, once that set of attributes is processed, it can then process the next set of attributes that have no dependencies except for the items that have already been processed. So in this case, region is the next attribute that we would see being processed. So what this means, if you think about this in terms of how it impacts your processing performance, the more attributes you have that are basically top-level attributes, the more that can start being processed in parallel. However, everything is basically going to come down to the key level, and as you continue processing, the key attribute of the dimension it has to be processed last because every other attribute within the dimension has a dependency, or it has a dependency on every other attribute in the dimension. So as you can see, we finally get down to processing the customer. Excuse me. And one of the things to bear in mind is as each attribute is being processed, analysis services has to hold all the immediately dependent attributes in memory for that processing. So in this case, when we get down to the customer key attribute, we're holding in memory also the income attribute, the gender attribute, and the city attribute. So this is where attribute relationships come into play from an attribute processing standpoint. Most people are aware that attribute relationships, and just to show you what I'm talking about here, let's take a quick look at AdventureWorks. And if we look at our date dimension, just close and reopen that, and go to the attribute relationships. The attribute relationships is where you define the hierarchy of how these attributes relate to one another. So we can see date is at our key level, dates roll up to months, which roll up to quarters, which roll up to semesters, and finally to years. So most people are aware that these attribute relationships impact query performance and can be used by analysis services to prepare better aggregations on the data and facilitate faster querying. They also have an impact on processing. And the reason is that, as we just saw in our example, if I were to process the date dimension, when I get to the point of processing the date key, then I have to hold all the attributes that it has an immediate relationship to in memory. So if I have a dimension that has no attribute relationships and it has 50 attributes, well, by default, all those attributes are related directly to the key attribute. So I have to hold all 50 attributes in memory while that key attribute is being processed, which can lead to extreme memory usage during the processing of the key attribute. So instead, we do want to have attribute relationships here. They're important not just for query speed, but also for the processing speed, because they reduce the memory footprint that each attribute has to have while it's being processed. So as you've may or may not have heard, you ideally want your dimension attribute relationships to look like a tree and not a shrub. So again, make sure that from a best practices standpoint, it's easy to build those things in up front as you're creating the dimension. It can be a little bit harder to add them after the fact. So attribute relationships are particularly important in this particular step of the dimension processing. The hierarchy processing is basically populating the hierarchy store. These do process in parallel, and generally they're not horribly time-consuming. If you have very large dimensions, though, the one spot that can take more time is ordering the members in the hierarchy. So this is using the order by information that you provide on the dimension. And we'll take just a quick look at that. So if I look at a particular attribute, I can specify the order by as key name, attribute key, or attribute name, and pick a different attribute to actually use to derive the order. So having that information can actually slow down the processing of the hierarchy. Again, this typically only occurs if you have very large dimensions. You can eliminate the ordering if it doesn't matter for your purposes by setting the attribute hierarchy ordered property to false, and this is done in the same place. Excuse me. The decoding stores is, again, a set of tables that are prepared that stored internally within the analysis services database that facilitate looking up high-level members of a hierarchy by the ID that is attached to a lower member. So this would give me the ability to look up very quickly the city associated with a particular customer if all I had was the customer ID. This generally does not present performance bottlenecks. It's very light on system resources, so usually no particular problems here.